Ah, perfect.
There we go. Cool. Urs Peter, my name for the ones who don't know me. Quick walkthrough. I try to be as much as possible with my hands in the dirt. Conference speaker for a few years now. Train at Java Academy, where I help basically Kotlin developers to get the best out of Kotlin, no matter whether you're a beginner, intermediate, or advanced. Also, if you're a seasoned Kotlin developer, there's still a lot to learn. I also have something with event-driven architectures. Yesterday, I also gave a talk in Amsterdam, combined a bit the two. Also, an interesting tool, which is more on the design level than really on software level. And when I look at my career, started basically with Java a long time ago. Then, about 10 years ago, moved over to Scala because, well, this was the kind of the next step for Java at that time. Until we found that, well, there is Kotlin, and since then, actually, mostly try to do. Actually, exclusively do backend logic in Kotlin, and front end, of course, there's a different story. So that's about me. Basically, I forgot the slide, which is about you. Actually curious. So who of you also programs in Kotlin? Okay, it's about half. Who of you is mostly writing code in Java? Okay, so about a 50-50 split, so that's interesting. Who of the Java people find Kotlin kind of interesting or think, this Kotlin thing kind of interesting? Kind of, let's see what this is. This kind of, okay. It's always good to be critical, of course, especially when you make a technical move. Okay, today I'm going to tell about, for a big part, actually, about differences between Java and Kotlin, why Kotlin is the way Kotlin is, and how does it relate to Java. So up to you and to choose yourself. And at the end, also going to show what you would embark if you would embrace Kotlin, because, well, of course, you can start something with a new language, but there is more involved than only a new language, right? You also probably need to get your peers up to a level. You need to kind of sell it to management and so on. So these all things we also might talk about. I won't talk about all aspects of Kotlin because we also have a nice presentation after this one. So all of the property stuff, delegation stuff, I will leave out. So this is then for you. So for the ones who have not heard of Kotlin, Kotlin is by now more than 10 years old, so mature language. And actually to 2016, not much happened. But then in 2017, it was announced to be the official language for Android. This gave Kotlin really a tremendous boost. And also Spring Boot announced first-class support for Kotlin. So, and what you'll see in all the frameworks out there, Spring Boot really has the very, very best support. So if you is using Spring Boot, see almost everyone. Yeah. Other frameworks, Micronaut, Quarkus. Ktor, yeah. Micronaut, okay. Quarkus, okay. Yeah, Quarkus, the Kotlin port is the worst. Also gave a talk last year about the difference between frameworks, Kotlin support and Quarkus. You see, it's not their most cherished species. It's still doable. What's kind of interesting is this graph, and you see that, well, you see actually this happening here, something. Scala kind of really, this is kind of data glitch, which is explained, but actually, from the time when Kotlin started to rise, Scala started to decline. So Scala really, took a lot of market share away from Kotlin, which I really understand because I've done both. What's important to realize about Kotlin is that the reason why it was designed is because Java had a lot of shortcomings. So the shortcomings of Java really drove the development of Kotlin. However, the Java ecosystem, of course, is extremely rich. There are great libraries out there, tremendous amount of libraries. So it would be kind of foolish to leave that aside, like Scala did. Said, okay, we just reinvent the wheel ourselves. We do all the libraries, reinvent them, but then better. Which is not a great thing. So Kotlin wants to be as close as possible to the Java ecosystem, and they go quite far to achieve that. So all the tools you see here. Familiar tools for Java developer, even Gradle, Spring Boot, and so on, just fully works with Kotlin. So here, kind of Kotlin Java sources intermingle together. Just can start out with some Kotlin in the Java project, and it just works. You need the dependency on class block, and that's it. But of course, Kotlin also has its own kind of frameworks. Like Ktor, we heard that's the web framework. even though I'm not really a kind of proponent of Keytor because it's Kotlin specific, I also prefer Spring Boot because this is what everybody knows, and Spring Boot really works perfectly with Kotlin. So a nice function library, own testing library, and this is actually the new edition of Kotlin. You have also Kotlin multi-platform, so you can write code in Kotlin, which you then can run on Android and on Android devices. Sorry, Android and iOS devices. And you also have Kotlin multi-platform, so you can compile Kotlin to all those targets, iOS, Windows, Linux, and so on. You can really make native apps with Kotlin. So without GraalVM, that's also a way to do native stuff, but really kind of native for Kotlin. And you also have Kotlin GS. It's more a fun thing, I guess, never really had big adoption. By now, really a tremendous amount of companies use Kotlin in the Netherlands. These are quite some well-known names. Also saw some people that work for these companies here in the room. Albert Heijn. Bol is really a big user of Kotlin. We also do quite some trading also with Albert Heijn. Also the banks, Rabobank, ING Bank, and so on. So Flexport is also a large company that uses it. So it's of course not taking over Java, but it really gains a significant portion of the market. I think this is a very important question, right? So especially when you're a Java developer and you get your stories done, right? I mean, it's not that you cannot implement the use case, you get it done. So why should you do the switch? So why should you even consider something else? And I think that's always a healthy kind of attitude, right? Because when you have a tool that works for you, there must be something that must be quite better and help you in various ways in order for you to let it go and step over.
So it's related.
Perfect. So the more the merrier. Cool that you joined. So for now, I would advise you keep that attitude, but also stay a bit open-minded. Try to maybe see things from different angles. And then I think we have a good evening together. We're going to look at various aspects between Java and Kotlin. That's definitely not the full story. Said won't be missed, and there are more parts missing. Also had to cut out stuff because, well, we have limited time. So I just made a selection of where I think kind of most important aspects that are worth comparing. And we start out with the paradigm I think most of you just know very well, which is object orientation. And we're going to just look at some Java class and then compare it. How does it look in Kotlin? So this will be the counterpart in Kotlin. And what you see is that Kotlin combines basically the field declaration with the constructor declaration. That's kind of an interesting pattern, which has also to do with safety. So what you can do in Java is have some no-argument constructor, but when you construct an object with an argument constructor, well, the fields might be nulls, you might get null pointers. In Kotlin, they intentionally, first of all, made it more concise, shorter, but also give you safety, because to construct a person, you have to go through these constructors, also if you would have auxiliary constructors. And by doing so, you're kind of sure that once you initialize the object, all the properties are initialized correctly, so you cannot get null pointers. So there's more to it than just short syntax. There's also a safety mindset behind that. So this can be removed. You also get the getters and the setters. So with the val, you only get the getters, an immutable field like a final one in Java. With the var, you also get a setter. So all this stuff you simply can remove. A tremendous great feature in Kotlin, which is so simple, but which you really start missing in Java, are default arguments. Right? Just give it a default argument, and then you have your auxiliary constructor. You don't have to define a new one. It's just there. You can use it for methods. It's so simple, but really, really tremendously useful. What's also very interesting, and you probably don't see the benefit right away, is that in Kotlin you don't have primitives and the box types, right? Like int and integer, or double and the double with the capital letter. Which doesn't mean they're not there, but Kotlin says, well, this is a compiler concern. So when I compile code, then I figure out that, well, here I should use primitive because it's more performant. So the compiler takes care of that for you. And this has really tremendous benefits, as we see later on, because now you don't have to deal with boxing, unboxing. This is just not a concern in your language anymore. And we'll see that this really helps you to keep code very clean and concise. Also, a nice kind of addition is interpolation. So you can have these strings, and then with the dollar, you would refer variables in your surrounding scope. You also have fancier ones are with triple quotes, which also come now in Java 21. You don't have to do the escaping anymore. Simply can write regex as they are, regex. But you also could use here interpolation, which then Java just didn't do again. So Java does a lot of things, but sometimes you forget just to go the last mile. Kotlin, it's all there. So here also have the curly brace, and then I can have here just an arbitrary expression. I could call a web service, just can execute code in there. What's also kind of cool, it's a bit of a more advanced feature, is that in Kotlin you can use a certain amount of operators to make DSL-ish kind of code. So if I use the keyword operator in combination with the word plus, and there are other ones, then I can use in my code a plus. Maybe this example is a bit stupid, doesn't make that sense, but it needs to be short. But in other contexts, it makes a lot of sense. So whenever you see a plus in Kotlin, it's actually something you can do yourself. It's not like in Java, it's reserved and nobody can touch the plus, right? Plus is kind of a reserved thing. Kotlin, you can use it too, which is applicable for all the most common symbolic operators. Nowadays, you have records in Java. Who uses records? Few ones. Has someone not heard of records? It's fine to say that you don't, because we're here to learn, right? So if you haven't, that's perfectly fine. All I've heard is records. Cool. Excellent. So, well, records in Kotlin you don't really need, because you simply can prefix your class with the data keyword. And then you get quite a few cool things. So what you get, what are really identical, is you get a nice toString implementation, right? A readable toString. So when I print this object, I get this particular string and not the hash code, the reference. Its equal implementation is by value rather than reference, right? And in Kotlin, you always can use the double equals, no matter what. Just will work. Don't have to use the equals method, which is, well, just a lot of typing. And what's really cool at data classes is that they have this feature which really lack in records, which is the copy method. The copy method works as follows: that I can take an existing instance, and I can, with named arguments, I can say which attributes I want to change. Whereas in records, you simply have to reinitialize the whole thing. And when you have only two construct arguments, that's not a big deal, of course. But when you have more, because you have a bit of data in it, it can be a bit annoying. Also, destructuring is something that Kotlin offers. So when you have data class, you get some code that allows you to destructure the elements, by the way, into that. See an example later on. It can give you very readable code in case you need that. What's really, really funny to see is that data classes, even when they're fully immutable, right? That's the whole deal about record classes, that you have immutable fields. When you have data classes in Kotlin, they just play nicely with GPA. We have whole domains with data classes, so whenever you do some mutation, it's really the copy method. We have a fully immutable domain, which is always better for concurrency and many other reasons. Whereas records do not play nicely with GPA. At least you can have entities as records. You can have DTOs kind of, so when you do queries, you could use records, but not for entities. And I found this kind of interesting because this is a Java framework, right? Builder patterns is something you see a lot in Java, right? The Lombok is probably also, you use Lombok, because otherwise it's not bearable to use Java. In Kotlin, you don't really need builders. You can make them even more advanced, but because you have these named arguments, they just do the job. No builder needs. So this is kind of obsolete. When people start out with Kotlin, what I often see trying them to do is putting Lombok in the project, because they think, yeah, without Lombok, I can't live. But that's really unnecessary, because all the feature Lombok offers is just in a language. Battery is included, so to say. What's also a kind of a simple thing, but really helps you in better kind of navigating your code, is that you can put multiple classes in a single file, multiple public classes in a single file. You don't have to, it's up to you, but you can. So this really helps me to kind of at one glance see how my domain looks like. And especially because the syntax is also short, with one glance you know what this domain is, whereas when you have to navigate all those files, it's a different story. Yes?
It's not possible in Java?
No, you can have the static inner classes. You can make them part of another class, but you cannot just have multiple public class segregation in Java files. Still not. Yeah, it's weird. So object-orientation, Kotlin definitely goes much further in it. It's also much more object-oriented than Java, right? Java has statics, has primitives, has void methods. In Kotlin, it's really purely OO. Everything has return type. There are no kind of primitives. So they go much further, and all the features seen is, I would myself would give it 5 stars, but of course make your own decision there. Let's look at functional programming. Nowadays, it's quite common, like functional programming. 10 years ago, it probably was a bit different, but I think the world has changed with that regard. When you have function declaration in Java on the declaration side, so to say, if you create high-order functions, that's the term for that, right? So a method that takes a function as argument, then you would have to use those functional interfaces. Who of you have used functional interfaces? Okay. Made also your own high-order functions? Not many. Okay, most time you use it like in the stream API in Java, right? And I understand it because using functions in Java, it's not that convenient. In Kotlin, they have first-class support for functions, which means they have a syntax for declaring functions. And syntax is quite simple. It tells you this goes in my function and this goes out. We have function declaration here. I think it's kind of readable. But if you have another kind of function interface like a long predicate, well, what goes in and what goes out? Maybe you know what a predicate is, but if you don't know, it's kind of probably something with a long. But when you read this signature, I see a long goes in, the boolean goes out. And because it's so much more readable, you also will be tempted to use this kind of constructs much more, because they really can help you tremendously in solving many, many problems in way more efficient ways than if you wouldn't use functions. From the call side, and here we also see the benefits of having no primitives. One of the reasons that we have all these function declarations in Java is because we still have these primitives and sometimes need to box and unbox things in functions. Tremendous amount of function interface only to make this possible. And sometimes you lack one, then you would have to use yourself. Because Kotlin has this syntax, well, it's all not needed. From the call side, it's not much different. So if you would call this higher order function, then you have a bit the same syntax here with just a variable name of the first argument of the lambda. You can use the method reference syntax, probably you've used it too. And Kotlin also gives you a shortcut with the it keyword. So instead of always declaring something, arrow something, well, you can use it. And in case it helps you to make your code just clear, use, I would say, a name. But if it's evident, like do with text, then probably it will be the text, right? So makes sense. What you also have is so-called functions without arguments. This is something where you can delay certain operations. And this is the exact same thing. In Java, we also have to use this empty and then arrow. And when you have to see an interface, it's a bit annoying. In Kotlin, nice thing is you have to use curly braces. That's what you need to do. But then you don't have to use an argument. It's kind of like a normal argument of a method. Much closer to that. Just a little bit of convenience there. So what you see in Java clearly is that functional programming was added later on. It was not designed with functional programming in mind, which is understandable, right? Because when Java was invented, functional programming was not something you could combine with OO languages. There were functional language or OO, was just not there. Later on, they had to add stuff. When you add stuff, you probably miss things, whereas Kotlin could be designed with functions as first-class citizens in mind from the base on. And that's why I see much better support in Kotlin. That's very interesting. Null safety. Well, why do you want to have something like null safety? Null pointers, have you heard of this exception? You have. Okay, that's interesting. You're an experienced programmer, aren't you? So when you have this interface, the interesting thing is this one doesn't really tell me all of it. It tells me that I can get an integer, but it doesn't tell me that I can get null. I don't know. And if you're a bit a defensive person, a bit scared, then you're probably gonna write code that looks like this. You're gonna check extensively for null. And in some cases, you're like, this is never null. I really know that. Famous last words. But that's not your fault. The fault is that this API contract here is simply not sufficient. The API contract is bad because it gives you something which might not be there. null. And the question is there a better way? Is there a better way?
Safety language.
Yeah, but in Java, there are still means in Java to overcome that. Exactly. So, well, the problem is you have quite a few of them. You can either use annotations or optional, but an optional can still be null. Right? You can assign a null to an optional, and I've seen this in code. Then you check for if optional is not null, and So also here you see it was not designed with null safety in mind. And when you add stuff later on, then you have to make concessions. Not Java's fault, it's just mindset wasn't there then. And then it's really hard to kind of evolve your language with such a crucial concept on nullability. Well, in Kotlin, the new null pointer exception is really a big problem. So just do away with them for good. I think they achieved that. So what they did is they created actually nullability and baked it into the type system. So in Kotlin, you have the normal types, like here, any would be the root, like object in Java. Here, int would extend. But then you also have some sort of counter type, which is the nullable counterpart. And the normal type is really a subclass. So they solved it with the type system. It's really a subclass of the nullable type. And you have to mark this with a question mark. And when you have this particular type, then you have to deal with null. So null I only can return if I have a nullable type. If you wouldn't have a nullable type, your compiler wouldn't compile. So here make a very strict distinction. This can be null, this cannot be null. And we have a lot of operators to deal with the case when something is null. Let's see how this is going to turn out when I have a whole domain that involves nullability. Because there you see the benefit of having null in your type system rather than with wrappers like optional. So what you see here is a domain with a booking, and a destination, there's a hotel has stars, and you see all these things could be null. Because, well, this is how your domain works, apparently. The nice thing is that if I create actually this whole domain, I don't have to use the wrappers. I just can use the domain class itself, not wrap it in optional. And now you have this beautiful syntax with question mark where I can navigate my whole object graph. And whenever something would not be null, it would continue. If one of the stages would be null, it simply would return null. So it makes it very convenient, easy to work with nullable values. What's also very nice is in Kotlin so-called smart casting. So if I check here for not null, then the compiler knows, wait a minute, I checked here for not null. Then I can downcast, so it's strictly a cast that is happening. It's called smart casting. I cast it from the nullable type to the non-nullable type, just the booking, and then I don't have to use question marks here anymore. Also quite convenient, without having you to cast something and maybe make an error in casting. So this would be the counterpart in Java when you use optional. And you see, this is just really not the same. It's way more complexity just because you have all this wrapper going on. A lot of flat mapping you would have to do, let alone if everybody knows what flat mapping is, right? To get really the same result. No smart casting here. So if I check here for is present or not, I always can call booking.get. That's always fine, even so it's probably not. It's kind of interesting that this kind of, it's probably not very simple feature, not very advanced, kind of intermediate feature is the most loved because it really gives you 33% less null point exception. Since I'm programming Kotlin, I actually never have null point exception. Sometimes maybe when you start an application and, well, you did some configuration stuff in the wrong manner, then this might happen, but generally it's just not there anymore. So also here, have to give Kotlin a bit more stars than Java. Let's look at control flow. Probably heard of the switch statement. Who of you is using switch? 1, 2, 3, okay. So with the break and the default and okay. You use it extensively? No. Because it's quite crappy, right? Because you forget the breaks, things like that. I mean, it's a lot of code. And what's also kind of limiting is that you can't even pass in objects, right? It's only primitives, enums, and strings, I guess, and that's it. That's what it can handle. But Java has improved with that regard since Java 21. Who's using Java 21, by the way? Okay, wow, that's quite a few. In production? Cool. 17? Most. 11? Okay. 8? Oh, okay. And I don't ask further because it's too painful, right? Okay, but since Java 21, so now it's final, they have pattern matching. And the counterpart in Kotlin would look as follows. In Kotlin, you have this when expression. You have two forms of it. This would be the most comparable. And you see you can do basically the same like with pattern matching in Java. So here you would, for instance, do a match on isInt, and then you get the smart casting again. Right? In Java, you just case an integer, then this is actually the cast where it's happening. And in Kotlin, you say isInt, and then it gets smart casted to an int. So here P is an int. This would be nullable, long question mark. This would be additional patterns. So you have the syntax string s, when, la. Kotlin, this is what it would be. Here again, if I have list star, then get a smart cast too. Kotlin also can match on ranges. Look at them later on. It's kind of a cool feature, which is not really possible in Java. But what Java can do is do destructuring. Have you heard of destructuring? So actually, what you do here is I have a product and assign me name and L of this product. And then this variable would be kind of magically be filled, and then you can use those variables later on. That's destruction. Take an object apart, right? Not construct, destruct. I think that's a nice feature, except that it's only applicable for records, not for normal classes in Java. You see that new features kind of are not really unifying and are applicable for everything. It's just limited to certain parts. Probably it's too hard to make it backwards compatible. In Kotlin, you would have to use this syntax. But I still think in Java, they made a good effort. They experienced a very long time, 17, 21. So I would give here a Java 5 star, because destructuring of data classes in event expression is not yet supported in Kotlin. So I think Java does a better job there. Extension is a gray mechanism. So what is an extension? Well, what you can do in Kotlin is you can extend existing classes with new methods and also attributes, but that's a bit of a fake. Basically, it's with methods like this one. So I have here an int. That's the syntax. I take a type, then I say a new method name, and then I implement here this method. And from there on, and this would refer to the int, right? So I could say this time this would see int times the int. And then I would have my square. And from there on, I have a square method on int if I import it. So it's nicely scoped. That's the name for that, right? So if you have an import that says my extensions dot square, then I would have the int, the square method on int. Kind of simple, right? Doesn't look very advanced. However, it is one of the cornerstones that makes Kotlin as user-friendly and compatible with Java as it is. Let's take a look. What you have, for instance, in Kotlin is cool extensions on collections with, for instance, numeric types. So now you can have methods only if you have a certain type in a collection. To have a sum method on all collections is probably useless because you might have collections where you cannot sum, right? It doesn't exist. And Java often has this. Java has some methods that just give you an exception because, well, you don't have this particular interface implemented. In Kotlin, you could even call sum on all lists. It's only on lists that have a numeric type. That's only possible because you have extensions. You have great extension methods on string. So utility kind of libraries in Kotlin you don't see because the standard library just has all you need, really. You have to be, I have never had the need, at least, to kind of build these kind of basic utilities. What's also cool is streaming, right? In Java, we also have these streams and try, finally, and wrap. In Kotlin, it's just all extension methods. I say URL, open stream, copy to, file, output stream, and so on. Buffered, so all the streaming stuff is just there, and they're all made available by means of extensions. There's also a cool one, so this would be in Spring Boot. You have this query for object methods where you also have to kind of pass in the class which you want to serialize. In Kotlin, you don't have to do that. They have an extension which gives you access by means of the type, so you don't have to provide the class. Just a bit more convenient. And you see these things many times in third-party extensions. So third-party libraries, they give you some Kotlin library, You can put on a class path, and then you get all these extensions for Kotlin. So that's why you can make Java library really feel like native Kotlin, because you have these extensions. Provide a bit of a glue, and then bats, just great to use. This would be some sort of optional for map. And testing. This is a matcher in Kotlin, should be, and you have many of these matchers, which allow you to write extremely expressive test code. Right? I could say 9 should be less than 10. Should throw, then this should throw this. Do some match with regular expressions. Some collection testing, and there's just a tremendous list of all these matchers available. So how can a string have a should method? Well, by means of an extension. These are all extensions, basically. Really cool mechanism. When you start with Kotlin, you don't really realize how many extensions you're using, but they're there. And the should is only there if you import it, right? So in your normal code, you cannot call should in it. It's only in your test layer where you can do that. So, well, pity that Java hasn't has extension. There you have the static utilities, right, where you put in an object and then it will just enrich something, but it's not fluent, not convenient, and so on. Kotlin, when you do extensions, will compile the static wrapper. So in Java, you could use the static wrapper, just get it kind of free if you would use this Kotlin code in Java. But in Kotlin, you would always use the convenient syntax for it. Okay, so then let's move to collections, do a bit of a live coding, I think, because it's fun, right? Then otherwise I talk much too much. There is a nice tool in IntelliJ. Most of IntelliJ, of course, also written in Kotlin. So let's see. So you have your project with Java and Kotlin sources together. It just works fine. What you can do is you have a so-called worksheet called scratch file. And this is what we have here. I put it here on top. And what you can do here is you simply can start writing code. Kotlin is so, guess what? Don't want to type too long. In the end, it probably takes me longer, but doesn't matter. So cool, right? I hit enter, and I get the result displayed on the right. So just by pressing enter, it will be evaluated. And when you do some prototyping or you have some complex algorithm to develop, that's really a great tool. Don't have to have a main method which to rerun it. Just Control S and will be rerun. I have here a few statements in Java. So Java collections. Here, create a list. What happens here? Any ideas? Very good. Did anyone see this one? You get an exception when you call this code. Which is kind of evil, right? Because it compiles. Because it's immutable collection, and when I add something to immutable collection, Java doesn't notice at compile time, it knows it at runtime, which generally is a bit late. Another thing in Kotlin is that you have so-called immutable collections, like the one we see here, 1, 2, 3. And so this would be my list. Let's show what's in the list. Well, these elements, and I can add values to my list. Even though it's an immutable list, this works because the original list L won't be changed. So what you get here is actually a new list. So no errors here. And these kind of things that you have compiling code and then exception runtime, actually in Kotlin doesn't exist. Maybe use a Java library, there it is, but in Kotlin libraries, it's something that doesn't happen. Okay, so let's move on. Well, if you want to do stuff in an immutable way in Kotlin, they want you to use immutable lists. So you have the mutable list of, like 1, 2, 3. So in Kotlin, actually want to use immutable constructs. In Java, it's the most common thing to use mutable collections. In Kotlin, it's actually something you have to choose for. I mean, you have to type longer mutable than list of. Because, well, immutable lists, immutable constructs by nature are just more robust in various for various reasons. So when I say ml plus 3, and I would type ml here, then, well, it would really have had this element added to the collections, just normal mutable collection. Okay, so what we try to do here is generate an even range from 2 to 10. Right? That's what's happening here. And you see a lot of complexities going on because you need to box, you need to stream, convert the stream. Well, I think by now it also have 2 lists, so we could simplify this a little bit, just convert from one to another. In Kotlin, you have a nice feature which are ranges. So you can say 2 to 10. And then only even ones, you can say step 2. And a range is a very efficient data structure. It won't just print the results. If you have a million items, you don't want to have them printed. You only want to have them when you really go through it. So if I want to have these items printed, then I would have to convert it to a list. Then I would see 2, 4, 6, and so on. Also, an interesting sample, what you do here, we have a map, and we want to swap the elements. Right, so the name should be swapped with the age. That's, again, quite a mouthful of code to make this happen. And all these kind of things are very kind of natural in Kotlin, as if you would just do it. So let's say we have map of, this is how we create the map, check 242, a map takes so-called tuples. They're built in Kotlin, so, and then you simply would map over the elements. And now I can use this structuring, could say name, age, because this is more declarative, right? And it value, it key. I could do that too, by the way, but just make it more clear. And then I could say age, name, and I have swapped the whole thing. That's what it is. So just kind of normal, natural operation. I had to look this up in Stack Overflow because, well, of course, when you do this on a daily basis, you will manage. But if you have to do it first time, probably need to look it up. Whereas in Kotlin, you just start typing. Here we have a list of products. We do some stuff with it. So I would say products, list of, and then let's see if we can copy paste this. I have a Kotlin. See, when I paste Java code in Kotlin, it converts it to Kotlin. That's a feature in IntelliJ. And I should have a product here. Yeah, so what I can do in this worksheet is say, okay, make it part of my sources. And then I should be able to import it. Yeah, but sometimes it doesn't work, especially when you do a demo. So let's see, I think I had it here. So then you can even use your project code, so to say. Now it accepted it. Okay, so what you do here is we have a product, and these are ratings, right? And we want to have the average rating of all. And here you see, go to a stream. When you flat map, you have to go to a stream again. Boxing, unboxing, mapping double. There's just a lot of complexity for something as simple as just give me the average rating of all the products. So what do you think I have to call here? I don't think there is an average by, but you could make it indeed. It's maybe one, but you also could do a flat map, right? And then you say ratings, then you get all the ratings, and then you could call the average. That's a bit the same thing that is happening here. And here is my average. Okay, some 2 more examples, and then we continue. What we try to do here is max rating per product. So we have all the products, the product names, and this would be the max rating if we get there. Just think out loud, so to say. How could we, which method do we have to use? Yeah, max of. But the problem is we still have to have the product name, right? Not only a single max. What? Very good, yeah, very good. That would be the kind of... and then? Ratings dot max, right? Also, max you cannot call because you also might get an empty list and then you would get an exception. This would be the wrong way around, right? So let's just so I said if you don't have the right operator, just do it simply. Say, okay, start with a map. We just map this thing from the name to the max or null. Like that. And sometimes IntelliJ gives you some hints to improve it. I don't know if it does it now, apparently not. No. Well. Okay. We've seen tuples, right? They're just built in. You don't have to have your own tuple implementation. And what's also very convenient is if I have to convert this to a map or a set, I simply can say to map, because there are tuples in it, pairs in Kotlin, so I can convert to a map. I can also convert it to a set, and then it will convert to a set. So if you convert collects from one to another, it's all just there. All these kind of convenient methods are available, and that's also because of extensions. And if you lack your conversion, you just add an extension with that conversion. That's why Kotlin can evolve from that regard quite easily. So, well, once you've used Kotlin collections, it's really a bit different than using Java streams or for loops. Well, so that it's really a great addition. Also, way more methods you can use. I haven't showed you all of them, of course. So every business problem that involves some really reshuffling of complex collections, if you combine multiple ones, is really a fun thing to do in Kotlin. I love those challenges because it's just kind of like a nice sport. Okay, so the last part will be about concurrency. So who of you has done something with low-level threading? Ooh, that's not many hands go up. Ooh, okay. And that's kind of normal, right? Because you actually want to stay away from these things. Who of you have done some reactive programming? Okay. Also not that many, which is the same like thread. You want to stay away from that, right? Well, I can tell you, if you use Kotlin, you might more be tempted to go into the realm of these kind of quite complex realms of software engineering, right? Concurrency is hard no matter which language you have, except that it might be much simpler if you get the right primitives. And this is actually where we're going to focus right now. So this is a simple example, again using Spring Boot, with some method calls in some REST endpoint. Right? We fetch some URL, avatar URL, we verify some email, and eventually we save this particular user in a database. And we assume that all these things are remote blocking method calls. Okay? So what's bad about those remote blocking method calls? Or is there something bad about them? They block, yeah. So when you have a lot of traffic on your server, and for instance, the verify email takes a very long time, and you have a lot of threads kind of waiting for the method, you might run out of threads. And when you run out of threads, what happens? What?
Exception.
Actually not. It's not an exception.
503. You get 503 errors.
Exactly. So nothing happens anymore. Yeah. No new requests can be accepted because there's no thread to listen to a socket. So it just your site freezes. It's kind of evil. So this is what can happen. Apparently, it doesn't happen that much because otherwise everyone would say, yeah, I know what happens. Because when you have enough containers and you don't have a nasty method that doesn't take a very long time, normally you're lucky and everything is fine. So that's why I think it's a fine model from an abstraction point of view. It's good code, right? Because there is no additional abstraction involved that's between you and your business case. It's kind of very easily relatable. Right? So I call an avatar, I get a URL, that's what I want. I verify email, get a Boolean. Well, nothing special there. However, if you would want this code to deal with a situation where we just described that when you have this tremendous amount of traffic and a method call takes long, you would have to rewrite it in a reactive way. This is reactive code. The advantage of reactive code is that these calls now, they are not blocking a thread, they are kind of asynchronous. And the way this works is that you get, at least Spring Boot, they use this mono abstraction. There are many ways in Java frameworks how they name them. Probably the term you've heard before is future or completable future. It's exactly the same thing. conceptually. There are some differences in how to behave, but conceptually same thing, which means that when I call this method, I don't get right away an URL. No, I get a kind of handle, the mono, the promise, the future, which eventually gives me a value or an exception. That's what you get, but not right away. And when it's very fast, well, it feels like right away, but actually there is always some latency in between. So I kind of set out the call, and I'm not going to, so the thread that did that is not waiting for this reply. This thread can do something else. So threads won't be blocked. That's maybe in a nutshell what is going on. Well, that kind of sounds good, right? And at runtime, it's also good. But for us as programmers, it's a nightmare. At least my own experience. Maybe some disagree, but does anybody disagree who has worked with these stacks?
And I agree.
It's hell. Because all of a sudden your code is not about well, users and URLs and booleans. No, it's about monos of things. So it's always wrapped. It's like if everything is an optional, but then a bit more complex. And then you also get these weird operators like zip, like flat map, like I can't even throw an exception. When I have an exception, I have to wrap it again. I mean, I can throw an exception, but then I get totally weird behavior. So normal program constructs, in many cases, I cannot use anymore, which really, really kind of increases the complexity of my code and basically blurs my business intent, because good code, I believe, is the one that depicts the business intent very clearly. When your PO can scan through the code and understand what's going on, I think you have written good code. So, by the way, here's something happening in parallel. Does anybody see what's happening in parallel?
Avatar and email validation.
And why do you know that? Which operator kind of tells you that?
Zip.
Exactly. So because he's a smart guy, works with this stack, zip does stuff in parallel. When you've never heard of it, you probably think, what the heck? This is where the parallel. So it's not very clear, right? I said, from a runtime perspective, this code is really awesome. It behaves, it is resource efficient, it cannot kind of halt your server, that's fine. But when this kind of code is not only on this snippet, but in your whole code base, good luck. And you also can you can do a lot of stuff wrong. If you still might block something, then you get even much worse performance. You can also reshoot yourself in the foot very easily. Kotlin also knew that, well, this asynchronous way of doing is something which with resource efficiency, is something that is important. And to be honest, that's not really from Java, that's actually more because Kotlin is also very strong in the Android space. And when you have a mobile device, you have to be very efficient with the resources, because you don't have just unlimited CPUs that do your work. You have to squeeze all the performance out which is there. And actually all the things we see here, which perfectly can be used server-side, actually stem from Android, where they kind of really battle tested that they make it, first of all, easy to program, but also highly efficient in their usage. So how could you kind of improve this use case? Quite simple, using coroutines. So what are coroutines? Well, coroutines gives you actually the best of both worlds. They allow you to express your logic sequentially, like you did in the blocking case, the first example we saw. But then at runtime, it happens all asynchronously, kind of wrapped away. So it behaves like asynchronous code, but to program, it's like normal code. And the only thing you have to do to make this happen, not really the only, but the most important one, is to make methods suspend. Use the suspend keyword for methods, which means that this method can be suspended for a certain amount of time. And then, this is a Spring Boot example, the only thing you have to do is in your controller, and that's really how it works in Spring Boot, you say suspend fun, and now all these calls are executed asynchronously, even though you don't see it. Highly resource efficient. Even better, you can use now async await. And I think most of us understand async await. That's in many languages, that's a construct which is well known. This means that to do these things in parallel, if both of them have returned, then we continue.
It's pretty much similar, like in .NET, right?
Yeah, quite similar. Yeah, but in .NET, it's a language feature. in the sense that, yeah, in Kotlin it's also a language, but in Kotlin this is actually a method. In .NET it's a keyword, right? Yeah, in Kotlin it's not a keyword, it's just another method. But the behavior is the exact same. Yeah. What's also kind of nice is that sometimes you have to use some Java libraries that are asynchronous. And then you think, I have these coroutines that are so great, and I still have to use this Java stuff. How does this interact? Again, piece of cake. You have extension methods that allow you to convert an existing abstraction into, well, a coroutine. So await single is an extension method on a mono, which gives me basically a coroutine. Yes?
Is this the same as in Java 29 when now with multiple threads, but then join?
Yeah, it's we will talk about that maybe, but we'll see. We have to see how it goes the time. I might talk about virtual threads if you want, which is actually the next thing. So, how are we doing in terms of time? Do you have 10 minutes or not? And really perfectly fine to finish up. It's also what the audience wants.
We have about 5 minutes.
Yeah. Shall we quickly go through Project Loom, or we want to have some live coding where I convert a Java application to Kotlin? What do you prefer?
Hands up for Loom.
Okay. It's kind of hard to do this in 5 minutes or 10 minutes. I have a good talk on it where it's explained in detail, so you can watch that. For now, just try to give you the boundaries. Well, you might have heard of Project Loom. Yeah, so virtual threads are a result of Project Loom. And what is actually this? So Java 21, you probably heard of it, have virtual threads. So what is a virtual thread? In order to understand it, we need to understand a little bit about the compute architecture. So at lowest level you have CPU, then you have so-called kernel threads. And when you look at the GVM, then actually a GVM thread is mapped to a kernel thread. And these kernel threads then fight for a time slice on a CPU by means of so-called preemptive scheduling. So that CPU just gives every thread a bit of time slice, and this gives you the illusion that you do something in parallel, even though you have only one CPU. You still have, as a user, think you can do things simultaneously, but that's not actually true. Only one thing at a time can happen. It's so fast, it feels like parallel. The problem with these kernel threads is they're quite expensive. So you can have, in terms of memory. So you can have only 4,000 threads per gigabyte of memory. And when you do something massive parallel, well, coroutines actually layer on top of it, which use or must be executed by thread, because whatever you execute on a GVM with a thread, whenever you execute something on GVM, you need a thread. There's no way around it. So coroutines are not bound to a thread. They will use the thread, but you can have many, many more. So you can have millions in a GVM, millions of coroutines. Virtual threads do conceptually this very same thing on a different level. They do it more on the GVM. So in Kotlin, it's something that is compiled in a code. When you compile code, Kotlin will kind of compile this in the code because Kotlin doesn't own the GVM, right? It's a host language. Java owns the GVM, so they can do this at the core. That's more or less what they did. So you have here virtual threads. You can also have millions in a GVM. And also virtual thread eventually need to be executed by a real thread, because I said you always need a real thread to execute something on a system. Instead of using normal threads, they have some dedicated so-called carrier threads. These are kind of threads that don't have any state. They are not even visible for you. It's kind of a magic thing. But in the end, it's just a kind of dedicated thread for these virtual threads. So traditional threads you normally would use for so-called CPU-bound work. So when you have a lot of like encryption or Bitcoin mining, well, then you have to calculate. These guys won't help you. Then you need bare bones CPU. But when you do a lot of I/O, with a lot of waiting in between, well, this is where virtual threads and also coroutines really start to shine. So from the outside, this is how virtual threads look like. It's the exact same interface. So from outside, you don't really see whether it's a virtual thread or a normal thread in Java. That's how they designed it. That's interesting. So also very good for coroutines. So from the outside, you don't know whether you deal with a virtual thread or with a normal thread. Same interface. What's really cool about virtual thread, this is the cool thing about virtual thread. the following. So when you use coroutines or just also reactive programming, it's actually the same. You always should use asynchronous libraries. We've seen that, right? You have to do these asynchronous calls, async database stuff, which limits you in what kind of libraries you use. You cannot use GDBC. You cannot use the REST template. You have to use the reactive counterpart. Why is that? Because whenever I do something blocking, I must not block a thread. Otherwise, my thread is blocked and then it cannot do something else. That's why I have to use asynchronous libraries. If you do something blocking, because sometimes you have to use a dedicated thread for that. Now, what Virtual Thread did is they retrofitted the blocking APIs in Java. And the blocking APIs in Java are kind of not so many. These are the blocking APIs. Java I/O, right? You do some blocking I/O. Sleep, thread.sleep is blocking too. And Java concurrent, when you have locks. I don't know if you work with Java concurrent, like latches is a bit more an advanced topic, but there you also blocking queue, things like that. So they retrofitted these things that when they're executed with a virtual thread, the underlying carrier thread, right, that's the thing that really consumes memory, is not blocked. So the virtual thread is parked, that's how they call it. In coroutines, they would call it suspend. It would be suspended until you get a response back, and then it would be resumed in coroutine terms and unparked in virtual thread terms. So it's kind of interesting to see, once you understand coroutines, you really perfectly understand how virtual threads work. It's kind of an evident thing, because it's conceptually the same. It's just on a different level. But two exceptions, synchronized blocks and native calls will pin the carrier thread. So then the carrier thread would be blocked. So this is the case where you really have to take care. So this is back to the future, right? So all these old-fashioned APIs we kind of left off because now we have this web client and all these fancy reactive libraries come back. In other words, this code here on top behaves better, or just works as efficient with the virtual thread as this complex code here with these monos and wrappers and all the misery we've just seen before. So that's really cool. So the future of reactive might look like that, except that we have talked about parallelism. So how can I do things in parallel? Now I just have non-blocking behavior, but I cannot do yet something in parallel at the same time. This is in Java where they have to rely on the so-called structured task scope. And probably that's what someone in the back of the room just mentioned. And well, this is how it works. So you have such a scope, then you can fork processes, then you get back a future. That's again the old Java future, but now with virtual it behaves nicely because it doesn't block anymore. So now I can do random avatar fetching and the email verification simultaneously. This is the code you have to write for that. So the nice thing is I can now use blocking methods to make things parallel without paying any overhead. That's the advantage of this code. But, well, I have this structured task scope, which has a bit of leaking API for get to join or get weird behavior. Of course, I still have to catch all the exceptions in Java. It gets the job done, but, well, it's better probably than reactive code, but still a bit cumbersome. And that's very important. This part is not live yet. This is still an incubator stage. But people think it's already there. It's not. Only the virtual threads are there. To make stuff happen in parallel, you don't have anything yet which is final state in Java. And this is actually the cool thing about Kotlin. So if you would have the same code in Kotlin, we can write a bit of glue code. So this is the exact same thing happens here in Kotlin. Exact same thing. The only thing I've done is basically written this glue code. So in Kotlin, you can make this API much more user-friendly. But as I said, it's still incubator, so anyway, I have to wait for that. What can you do now? That's the interesting question. Well, now, let's talk about quickly some limitations of Loom. Loom structured compared to coroutines has some limitations. Coroutines is a better implementation. I'm not going to go into details. You can watch this in my talk. Coroutines is more mature, better in quite a few ways because Java had to also do some limitations because they implement on the thread level and There you just cannot move as much as you can do with coroutines. So same is true of reactive streams. Maybe skip this one because not many use reactive streams. But the cool thing is, because the thread interface is the same for virtual threads and normal threads, I can now also execute a coroutine with a virtual thread. The coroutine doesn't know that it's executed by a virtual thread. And then you basically get the best of both worlds in the sense that, first of all, these kind of annotations work. They wouldn't work with virtual threads. I can now use blocking method calls in my coroutine code, which before I could, but I had to make some special precautions. Now I just can use any blocking code in my coroutine, but still have async await available. So I still have all these parallelism primitives at my disposal. And I can use it today, because the only thing I need here is a virtual thread and not the incubator part, which is still on the development. So this is basically what it is. These are coroutines, but with virtual thread, they're really getting completed. That's the good news. So Kotlin might profit most from Loom, even once it's finished, because you have this DSL feature to make it much more user-friendly, and because you still have coroutines where you can get even more functionality out of it. So I think Java does a better job with concurrency, right? But so it's a nice step, but yeah, probably Kotlin will profit most from it. Okay, so let's do a quick verdict. So these are the stars, and that's of course up to you, but you won't get the same amount of stars. Probably won't. How can you kind of summarize it? What I see is that when you use Kotlin from a distance, you get 40%, as I call it, more code clarity. You get, of course, less code, but it's not just less because, well, you can write these one-liners nobody understands, but you get actually more clarity because the relevant information is depicted and all the fuzz, the boxing, all the stuff that is actually relevant is just not there. Only the relevant stuff is there. So you get 40%, that's a lot. 40% more code clarity. On the other hand, you also get much less bugs because there are a lot of safety features in Kotlin. We've seen it with the constructor, with null safety, with the immutable collection. It's just a much safer language. So 25% less bugs is significant. You will feel that because when I started programming Java, I also had immediately null pointers and thought, whoa, is it me? No, it's not your fault. It's a language fault, really. So, well, and will Java catch up? Java does tries to do a good job to kind of be a modern language, but certain core features, like you see, null safety, function programming is not really there, obfuscation, you still have primitives, collections. The core stuff in Java is kind of broken. And you can, of course, add new stuff on top of it, but you probably won't get this unified, beautiful whole which just works because, well, Kotlin could enter later where all the experience Java had, also the pitfalls, they could use to make it better. That's the advantage when you have a language which you develop later on. And maybe in 10 years, Kotlin has the same phase. There comes a new language that, I don't know, maybe it's very suitable for AI, and then also Kotlin might suffer from that. So I think that's also something which is natural for language evolution, not particularly applicable for Kotlin or Java. Okay, so because I'm really over time, maybe some questions?
I have one.
Yeah.
What relation there is between the versions of Kotlin and Java? I mean, for example, you start a new project, I don't know, in Maven, and you put, okay, you will use Java 17 and Kotlin 1.8. Can you say, no, I want to use the same Java version, but with Kotlin 1.9?
Yeah, it just works. No, Kotlin is not bound to a GVM version. You just take a GVM version. Of course, if you use virtual threads, then you have to use Java 21. But if you don't use Java-specific stuff in these GVMs, you just can use a GVM, whatever you want, 11, 17, 21, even 8 still works.
Okay. So it's mostly performance then? The performance wins of a newer GVM?
Yeah, they optimize certain things, yeah, because they use then the native blocks of this GVM, and for the rest, it just keeps on working. So switching from a GVM version, that's also now, I think, so when you have new language features, In Java, you have to wait for JVM, and big companies, it's quite a process. Oh, new JVM, is it safe? You have to do testing more. In Kotlin, you just upgrade latest, and it works on the JVM you just chosen. So you can evolve much quicker with Kotlin. It's very common in Kotlin that you increase your version. It's kind of a very normal thing. Yeah.
So it's including the common version.
Yeah. Yeah, it's just bytecode, right? The Kotlin compiler spits out bytecode. And bytecode runs like all the host languages, Scala, Groovy and so on. They just spit out bytecode, and this is executed by the JVM. That's what the Kotlin compiler does too. Okay, so maybe the rest during the break, because you also want to, of course, a very interesting presentation. Thanks a lot for listening, and